Welcome to September 7th LeetCode Challenge, Reverse Linked List. Given at the head of a singly linked list, reverse the list and return the reverse list. So we're given a linked list here. Say we have head being 1 points to 2, points to 3, points to 4, points to 5, and we want to return that, but in reverse. So it'll be 5 points to 4, points to 3, points to 2, points to 1. So yeah, that's pretty much it. 1 points to 2, then 2 points to 1. And if it's empty, return empty. So the constraints are nodes are within the list ranging between 0 to 5,000 and no values between negative 5,000 to 5,000. So yeah, that's pretty straightforward. Let's see, can all linked lists reverse either iteratively or recursively? Can you implement both? Let's see if we can do both here. All right, so pretty much the first one I'm going to try is iterative approach using 2 pointers. So this is one of the most basic type of questions you get asked in school and for projects and stuff. So it's good to wrap your head around kind of linked list, and being able to reverse the linked list is kind of the best skills you can learn or have at least in the back of your hand. So the idea is to keep 2 pointers from the current node that we're on, and then the next node that we're gonna go on. We're gonna iterate through those nodes and reconnect the nodes, reconnect them from the front to the end. So the best to understand the solution is to take a small list. For example, we have 1, 2, 3, 4, 5 connected to none, right? The last node is always none, and we want to see where each steps go. So let's say we have the current node is I'll just make the code and then we'll talk about it. So say we're gonna have a variable binder here. So current is equal to none. So point, and then we have next. Call it next, I guess, being head. So we have a current node, a current variable pointed to none. We have a next variable pointed to head. So this points to the beginning of the linked list. So it's pointing to the first one there. And then our iterative approach is basically going to have 2 pointers, and we're going to move around, and we're going to basically do a handshake here. So for iterative approach, we're going to have while next exists. What we're going to do is that we are going to have a temp node here, and that's going to be next node. Call it node actually, or yeah, node.head. Node.next. So the temp node is going to point to the node after it. So we have a point to describe. So we have basically current is equal to none right here, up here. We have node pointed to head, and now we have a temp pointed to node.next, which points to number 2 right here. All right, while node exists. And then we have node.next. It's going to point to current node. Then we have current pointed to next to the node. And then we have node assigned to be temp. So that's pretty much it. So we have a temp holder pointed to the node after the next one. Then we have the next node pointed to the current node. We have current node pointed to the actual node holder, and we have node pointed to temp. So this is a 3-way handshake here we have going on. And then this keeps on going while node exists. So when it gets all the way to the end, node is equal to none. Therefore, we exit the loop and we return our current. Let's run this code. Our current, which is basically the entire reverse linked list, hopefully. So finish, looks the same, submit, accepted. So this is the iterative approach using 2 pointers. Space time complexity is big O of n because we have a while loop here, which runs through the length of size of the node, which is basically the size of head, which is the how many values you have inside the linked list, which is big O of n times. Space complexity is big O of constant space because we would just return the the linked list as a variable. Alright, that's the iterative approach. Let's see if we could do the same thing using recursive. So, same deal as before. Let's say if, let's say head is equal to none, or head.next is equal to none, then we want to just return head, right? That's when it's empty. I forgot to do that with the previous, but it shouldn't matter. Just save us a little bit more time. So we are going to have, let's say, new head. No. Yeah, new head. This is going to be the reverse. Call reversed. Reverse. Yeah. No, that's not a good name for it. Call it new head. Self dot reverse list using head.next. So this is known as head recursion. So the recursive call is the first statement in the function. So we have basically this returns if it's empty, return the head if it's empty, or there's nothing following afterwards, or if it's a single node. And this is called head recursion because we're using the recursive call right before anything else starts. So here's a little bit of a mind bender here. So we have something called head.next, and the one after that .next, we want to reassign that to be pointed to head, and we want head.next to be pointed to none. And then we just return our new head, right? So head recursion, the recursive calls the first statement in the function, therefore we just basically reassign the head.next to head, and then head.next to none, and we just return head new head. And that looks correct. Accepted as well, awesome. And this one is big O of n log n. Let me see. Space complexity is big O of constant space, I believe. And recursive case is big O of, yeah, I think n log n. No, yeah, big O of n, just big O of n, and space complexity is big O of n as well. My apologies for that. So yeah, that's pretty much it. Have a great day, guys.